One thing we're going to want to know as we move forward is we're going to want to know where the electron is located. And helping us will be the following fact. The square of the atomic orbital gives the relative probability an electron is at a specific position. And that's a hard sentence to understand. That's position. And I'll give an example. And I'm going to draw it, and then we'll see with my crude drawings, and then we'll see it in the PowerPoint. We're going to look at that 3py orbital. There's that big lobe, which again I'm going to make here a negative. Then there's the small lobe, which is positive. And then negative. And then positive. And what we saw before was we're going to compare several different points. We'll compare the nucleus in red versus here in the center of this lobe, which I'll make a purple. We're going to compare, and then we'll consider this point right here between the two lobes in black. And finally, we'll consider the center of this guy here. So we're going to consider those 4 points: red, purple, black, and aqua. So that is the atomic orbital drawn on the left, and we know that the R function looks like this. This is what I drew before. The R function was big here and small here. And where on this is the R function? This circle right here. Yeah, I'll just put it right here. This circle right here that I just dotted, what color is that? Red, purple, black, or blue? Put it in chat. Good, that's red. And what's the color of it here? At this top point right there. Red, purple, black, or blue? Aqua. Put it in chat. Put it in chat. That is purple. Here. What color? I put a dot line. What is that? Red, purple, black, or aqua? Put it in chat. That is black. And finally, this point here is aqua. So, that's the value of R. If I want to know the relative probability of these 4 sites, what do I have to do according to the statement above? And the answer is the square of the atomic orbital. And R is a manifestation of the atomic orbital. The square of R gives us the chance an electron is at a given position. So which of the 4 colors is it most probable that the electron is located there? Put it in chat. Red, purple, black, or aqua? Put it in chat. Purple. Where is the second most probable place that the electron is located? Put it in chat of the 4 colors. Aqua. And probabilities are positive or negative. Probabilities are positive or negative. Put it in chat. Probabilities are positive. So it's the second most probable here. And then what is the probability that the electron is at the red or black spots? The value of R is 0. So the square of R is the relative probability. The probability, put in chat, what is the probability? It is 0. And if we connect these points, we get this graph. And this graph is called R squared. We're not done. All we've done is compared those 4 points. But what we would also like to compare is the entire sphere. There, that's the blue sphere. That's the purple sphere. So there's a sphere going around the nucleus, and there's a sphere here in aqua going around. And while that individual point on the aqua was less probable than the individual purple point, there's a much bigger sphere of points on the aqua. And because there's a much bigger sphere, is it more probable that the electron will be at the aqua distance or the purple distance? So the question I'm asking is, because the electron, we're now considering how far away the electron is. Anywhere on that huge aqua sphere will count at being at that distance. Anywhere in that tiny little purple sphere will count at that distance. Will that end up making aqua more or less probable? Put it in chat. Will it make it more or less probable? It will make aqua more probable. And so we now get this new graph. It's still 0 for the red and the black. But now when we consider the whole sphere, the purple becomes smaller in value and the aqua becomes bigger in value. And the graph looks like this. And this is called the distribution function. And the distribution function takes the value of capital R squared and weights it by the area of the sphere. So the distribution function is equal to 4 pi little r squared, that's the surface area of a sphere, times capital R squared. So there is capital R squared, and capital D. And now let's see what it actually looks like. There. This is the R function. And here's R squared. Just as advertised, the purple spot is highest and the aqua spot is second highest. Here, that's just shown down right here. R squared. You can compare the two. And finally, we can look at the D function, which is here. And the D function in D, the aqua spot gets bigger. And just like we had here, it got bigger. And that's the D function, where we weighted by the sphere. And one final concept will be in what regions is it most probably found? And a kind of simple plot you can make is this one. Just consider a threshold. So the least probable distances are the ones shown below that green dotted line. We're just going to plot the points above the green dotted line. Those are the only positions that we're going to draw for. And if we did that, we would end up with a picture like this. Only in the region shown, those two crescents, the two big crescents, the two little mushrooms, that's in the place where it's most likely. And this is called the cross section, the place where there's a 95% probability the electron is found there. And we'll work on these things in post lecture and so forth, and you'll get more and more familiar with these concepts.